So welcome everyone. This is Frederick Winsness with NetHope. I want to welcome you all to another NetHope Solutions Center webinar. Today we're going to be talking about the biggest problem for humanitarian unmanned aerial vehicles is big data. And we have both Esri as well as WeRobotics to be presenting today. I will quickly go over our standard housekeeping rules before we get started here. Please make this as interactive as possible. We will do a Q&A session towards the end of the hour today, so please open the chat window in WebEx and line up your questions there. We are recording this as always, and please look for a follow-up email with recording and the pointers to the collateral on the NetHope Solutions Center. And at the very end of this webinar today, you will find an online survey. It'll pop up on your screen when we're all done, and we'd certainly appreciate you answering those few questions as you exit the webinar today. And with that, I want to introduce Brendan, or Brendan O'Neill. He's a solution engineer in the nonprofit and global organizations group at Esri. And we have Andrew Schroeder, co-founder of WeRobotics, and he is also the Director of Research and Analysis at Direct Relief. And without any further ado, I'm going to turn it over to Andrew. So, Andrew, or maybe, I'm sorry, maybe it's Brendan that goes next, so whoever's going to go next, please go ahead.
No, Fred, I think it's me. If you could switch over to my slides. There we go. Thanks, Fred. And thanks to everyone for joining. I hope you can hear me okay. As Fred said, my name is Andrew Schroeder.
We can.
And I'm going to be going over issues around humanitarian drone deployments and specifically how big data sits within the complex of a number of other issues. I don't mean to suggest that it's the only problem, but I do think it ultimately is the biggest problem that we face. And Esri has been really a great partner of ours in helping to address a number of these solutions. So I'm looking forward to presenting some of that to you. So WeRobotics is a global nonprofit organization. It's fairly young. It's about 3 years old, and it focuses on localization of appropriate robotic solutions to address key issues in aid, development, global health, environmental protection, et cetera. The focus on localization is important. We are focused mainly on the humanitarian principle of localization, so ensuring participation in the technologies of the Fourth Industrial Revolution, and the practical implications of localizing robotics and specifically drone technology. So ensuring that we're able to sort of act using the technology as efficiently as possible, which in our view implies localizing in a number of different ways that technology so that it's proximate to the space of use. We do this through creation of flying labs, which are partnerships that activate the localization process for the use of robotics for social good, and they're distributed in a number of countries around the world. So our first set of labs is started in Peru, Nepal, and Tanzania, but has expanded South-South collaborations across 12 countries now. And you can find more information about that at werobotics.org. The goal of this is, again, not only to ensure that the technology is proximate to the space of use, but that we're building networked collaborations among actors throughout the Global South. And I think one of those key spaces, as we'll discuss a little bit later, is around big data applications. one of the other sort of key pieces to introduce here, I think, has been the development of the UAV Code of Conduct, and the principles of localization are embedded in the UAV Code of Conduct, as well as the issues of community engagement that emphasize that all drone activity should make every effort to engage communities where they are, explain what's being done, flight patterns, access to data, et cetera. So as always, I want to emphasize, go view the UAV Code of Conduct for all of these kinds of issues at uavcode.org. This is a new website where you can access the entire UAV Code of Conduct. So a lot of what I'm going to say extends from experience of the last year, where WeRobotics worked with a number of different parties through UNICEF, UNDP, and the World Food Program around humanitarian drone missions in Peru, the Dominican Republic, in Myanmar, Malawi, Tanzania, the Maldives, Mozambique, the Seychelles, and encountered actually many of the same issues over and over and over again. And the concept of making sure that the data layer is secure throughout all of these areas was a consistent finding of every one of these missions. I wrote this up for Radiant Earth. It's on Medium. So if you go to Medium and search it, you can find the article on localization of humanitarian drones and lessons learned from the case studies that I just described. And in here, one of sort of the kind of finding around sort of localization and data throughout all of these cases was that flying is sort of the least of our concerns when we're dealing with drone applications in humanitarian response. In fact, actually, the least amount of time is spent in these applications actually doing the flying, and this is on a curve downward as more and more of the actual hardware and flight controls are automated and are designed to be operated by a relatively low level of technical expertise. Obviously, that changes as you go to higher end drones or more specialized sensors, but across the board, the vast majority of time was spent in planning and in making sure that all of the other conditions around the drone operation were secure. And that includes planning around data management and analytics, and ensuring that we're able to create an appropriate feedback loop so that data is driving how we do this work. And if we can reduce that planning time and improve the time that's actually spent on the analysis, I think the goal is to make sure that the time actually doing disaster response improves. I think often in some of these discussions we get a little fixated on the technology itself, but the point of humanitarian drones is not actually to fly drones. The point is actually to enable disaster response. So we want to make sure that planning time and flight time are minimized so that the utility of the data is maximized and ensure that we can spend the most time working. Just a couple of other, kind of contextual issues around other things that make a difference here in drone applications for humanitarian response. One is just geographic considerations. The finding from the Maldives really is that the local geography makes it an enormous difference. The Maldives has regular low-level disasters, flooding disasters. The archipelago is distributed widely over 1,000 kilometers of open water, and if you don't have access to the technology, including the ability to transfer and manage and analyze data, it's almost impossible to make effective use of the technology. So ensuring in this case that we're utilizing community emergency response volunteers and other other folks that are more proximate than, in this case, the capital, which is down in the southern part of the country, is one of the important issues to consider. And this is was a finding kind of across the board, that geography makes a huge difference given the need to be proximate to the space of action when you fly humanitarian drone missions. Likewise, partnerships and permissions make an enormous difference in this work. In the case of Peru, we worked closely with colleagues at INDESI in the Emergency Telecommunications Cluster and colleagues at the World Food Program that helped to facilitate partnerships that enabled just the legal right to fly. Again, often these have to be done in the context of familiarity with the civil aviation structure, with the folks that are actually working locally on relevant applications. So localization makes an enormous difference just in terms of being able to manage the legal structure around this. The data issue starts to come up most specifically around data connectivity and speed. So disaster response is obviously a need for high-speed action. We have sort of identified across the board key sort of limitations around bandwidth in remote areas, bandwidth under conditions of damaged infrastructure, and the ability to move data around, as well as to analyze and extract useful information from that data, feeds back directly into whether or not drones are ever going to be a truly useful technology for disaster response. In this case, in Mozambique, we were operating entirely without internet, and we're having to move data via SD cards, finding significant limitations in just being able to transfer from drone to processing environment, and then limitations again around the time spent in actually processing and then drawing useful information from that data. And that kind of leads into the big problem, which is data scale. So presuming that we can actually sort of, transfer data into the processing environment, make sure that we have, the ability to process it, the ability to actually push into a GIS environment to analyze it, we're talking often about large amounts of visual data that is, needing to be managed often in remote environments or under conditions of damaged infrastructure. This is a multispectral image taken in Tanzania, so probably not the kind of leading form of data that one would encounter during a disaster response, but in this case, which this is not a very large area, it's 500 hectares, which is composed of 6,300 images, which produces 15 gigabytes of imagery in 4 bands, and using a pretty conventional laptop that was taking 24 hours worth of processing time. Obviously, in an emergency response, that's really not acceptable. So if we want to make this data useful, we need to be able to change this, this dynamic. Just to really quickly review some of the bottlenecks that come through drone data products. I mean, there's several, with analysis kind of being the last one. There's a bottleneck in transfer from the drone to the processing environment. So we need to be able to move data from hardware into a software environment, into a web GIS. The actual processing of that data is often a bottleneck, particularly in remote environments. The processed data may actually sit just as tiles or images on the laptop unless we can actually upload that data into a shared environment. Obviously, under conditions of damaged network or limited bandwidth, that's quite challenging. The management of databases and services often requires a kind of significant WebGIS investment in the field environment, so obviously that's another kind of choke point. Feature detection, modeling, and the derivation of kind of valuable information, either analytical conclusions or vector data that would contribute towards answering certain important problems, such as where are the greatest intensities of damaged infrastructure, where do we have obstructed transport, where do we have fields, agriculture, forestry that's been impacted by an event, how do we convey those learnings to those that need to make decisions, that again is then another choke point, often is also paralleled by the need to make sure that we have appropriate staff that can actually do that analysis on site. Often then making sure that we're sharing what's appropriate information, not only the imagery itself, but the derived information that speaks to the questions that folks have about how disaster response actually should be carried out. So again, we want to make sure we're maximizing the time working and not spending our time looking at imagery. So I think figuring that data pipeline out becomes then of paramount importance. One answer that we're applying towards this is the OpenAI Challenge, which was issued in conjunction with the World Bank and started with a project in Vanuatu looking at how we could do automatic feature detection to identify particular trees that were affected by Cyclone Pam. In this case, we had AI and machine learning researchers that were looking at open feature detection, classification of vegetation, land use, damage detection, et cetera. And we were able to announce the results of that on May 15th at MIT, in which case Simon Fraser University and ETH Zurich were able to contribute really outstanding work to automatically detect the trees, the particular type of tree, and the damage done to the landscape. So that, I think, is part of a vision of being able to create an open library of machine learning classification that incorporates local knowledge as well into identification of relevant variables for disaster response. Speaks, I think, to things that Brendan will also address in terms of Esri's approach to the same questions. Just quick to lead into some of the work that with Esri in December, Tanzania, specifically Dar es Salaam, had some of the worst flooding in about a century, and the Tanzania Flying Labs was engaged by the Dar es Salaam emergency response team to provide drone support, imagery support that would allow them to do rapid detection of impact on affected communities in this area. You're looking at the Mbezi River, and this is the post-flooding imagery from the Mbezi River. We were able to coordinate directly with, because we were already on site with our Tanzania lab, we're able to coordinate directly with the civil aviation flight control via WhatsApp groups, which was a very effective way to be able to engage that permissions process that I mentioned earlier, and then to get 3 flights out using the EB drone by SenseFly to capture wide area, high-resolution imagery of affected communities, and then enable comparison of that to existing satellite imagery that would be useful for damage detection, change detection, other kinds of issues, understanding impact of the flood. Being able to eyeball this through simple viewing of the imagery shows the cloudy area in a section of Dar es Salaam called Boko is the imagery that was available as of November 2017 from Digital Globe, and then the imagery that is clear is the drone imagery captured via EB, flying underneath the clouds. But you can still see in that imagery that's clear from the EB an enormous amount of visual information, both in terms of areas of impact from water, structures, roads, and other information that would be, even given the clarity of the image, extraordinarily valuable and time-consuming for emergency managers to be able to access and draw conclusions about. And that, I think, is where Esri really comes in terms of being able to integrate imagery quickly into a WebGIS environment that allows us to do that kind of analysis. So I'd like to hand it off to Brendan to go through the Esri platform and how that relates to what I was just describing.
Sure, thanks, Andrew. Yes, I'm really going to focus on a few of the points you mentioned as bottlenecks, that being mostly being able to manage your imagery and share it so that you can gain useful insights out of it through analysis. And when we think about using or processing drone imagery so that we can create information products, useful information products out of it in the case of a disaster response or humanitarian response, from the Esri's perspective, we really have two kind of workflows that I'm going to be going through. One is this simple drone to map to outputs. That could be local TIFFs, for example, local imagery they can work with in ArcGIS Pro or ArcMap. But also you can publish those directly up to ArcGIS Online or your ArcGIS Enterprise. But then I'm going to take a little bit of time talking about this more robust workflow that leverages Mosaic Datasets. So this framework for cataloging metadata around imagery so that it's easily discoverable. And I'm going to introduce you to these drone to map output management tools that really streamline the creation of these Mosaic datasets, and then how you might be able to exploit this framework in ArcGIS Pro, or even publish your mosaics up to ArcGIS Enterprise. So when we think about drone to map, we're really thinking about pulling in single frame imagery from drones or other aerial aircraft, and then creating these different outputs, right? We have 2D imagery products like orthomosaics or DSMs, digital surface models. We can also generate 3D point clouds, so LAS data types and meshes. These are important if you wanted to, say, generate volumetric calculations. You can do that just using your single frame imagery from these drones. But also there's an inspection mode where you can actually exploit the specific images that are being captured for damage detection, change detection, these types of things. And we'll show you a little bit about that later. And the simple workflow is just that. It's very simple. As Andrew showed in his graphics, flying the drone is actually a very small component of at least the state of drone operations now. There is a bit of a hit when you get into processing that application as far as time, but with larger compute resources being thrown at your processing jobs, that is shortened, of course. But as soon as you've processed that imagery, it's instantaneously useful for you. You can publish it directly from drone to map to ArcGIS Online or your enterprise, or you can work with those products directly in ArcGIS Pro. It's a very simple process. It'll take you 30 minutes or an hour to really learn how to transform your single frame images into information products that you can use in your GIS. But then we have the more robust model, right? So after we've generated our orthomosaics or our information products, we're really, when we think about this robust model, we're talking about not just flying 1 or 2 flights in the case of a response, but think about a large-scale response where you have multiple actors that are flying multiple missions that might last, a month or 2 months, where we get to this scenario where we have a number of different information products, a number of different raw images that are out there, and they're not really coordinated in any way. They might be on people's laptops. They're not centralized in this repository. what we would do is look at that and try to merge all of these information products and raw images into Mosaic dataset. As I mentioned, that framework for organizing. Essentially what these do is they store footprints for your different images, as well as metadata associated with that. That could be the date of capture. That could be the cloud conditions, if we're talking about satellite imagery. Anything that you want to record against those imageries, the images you can, and store them in the Mosaic so that you can then filter and discover the different images you have. When the images are ingested into this Mosaic dataset, they can be used on your desktop directly or published up to the web for use in your desktop, web, or mobile applications as well. And I wanted to highlight a few resources for you if you are in a situation where you're managing large amounts of imagery, whether it's satellite or aerial. I encourage you to take a look at this link here at the bottom in yellow. This is a great resource for finding tools and best practices for managing large amounts of imagery. Whether it's doing it locally or in the cloud, I encourage you to take a look at that. And specifically when we're talking about outputs from drone to map and working with drone imagery, these drone to map output management tools, which can be found from those imagery workflows webpage, is especially important. What this does is allows us to directly ingest all the images and products from a specific project that we've flown in drone to map, and furthermore, it allows us to assemble those different projects into this master collection, this master orthomosaic. And this may sound a little bit abstract right now, but I'll show you in just a moment a demonstration of what this looks like. Essentially what we're doing is we're pulling in the different single frame images and the orthomosaics and the digital surface models from all the different projects we have, and then indexing them in one single Mosaic data set that we can use as a catalog to find our information. So it's really simple but really powerful. And lastly, once we've got our Mosaic data sets in an order, this is that last piece where we're trying to find or gain insight from the imagery that we've collected. There's a number of different tools that we can use. I'll show you Web App Builder as a way to share out your imagery so that it can be exploited by you in your workforce while you're in the field. So rather than just talk about it, why don't we take a look at some of the technology. All right, so I'm hoping you can see my screen. So what we're looking at right now is the flight plan for the Mosaic River in Dar es Salaam. This is one of the regions, one of the 3 flights that Andrew mentioned. When we're generating our outputs from drone to map, it's really simple. We go into the processing options and we choose the different products we want. The drone to map output tools that I'm going to be showing you, they only work on 2-dimensional products right now. So 2-dimensional products would be your orthomosaics, your surface model, your terrain model. There's a number of different parameters in here. Basically, you set them, you determine what outputs you want, and then you hit start, and that gets the job going. And what you're seeing here is that with the flight path, each one of these blue dots is a single frame image that, when processed and stitched together, generate these nice orthomosaics, right? Really high resolution. We also have the output for the surface model, the terrain model. We can do, like I said, volumetric calculations on these things. And it's really easy to get from this information product to using it in some sort of useful application. All we would need to do is just share this image directly to ArcGIS Online or into our enterprise, and then we're able to work with it across the platform. And I'll show you that now. Really quickly, the plug for this is the imagery workflows. There's a number of different tools that are there. And then this is that location for the drone to map output management scripts. If you download those, there's some really good documentation, a great PDF in there that will walk you through the purpose for these tools and how to get started with them. But before that, I wanted to show you that workflow where we had we've got our 2-dimensional information products, our orthomosaic that's been shared. That's been created with drone to map. And then it's really easy to get it up into the enterprise. I can go to the NetHope Esri webinar collection, and we can see that I've got a number of different layers here. We've got the Boko area mosaic, the Jangwani River mosaic, and then we've got that Mbezi River mosaic, which is what we saw earlier. So we have all these different layers that we've generated from drone to map that we can then mash up with other different data layers, right? And I've taken the liberty of generating one of these applications for you. So it's a really simple application. It's got bookmarks for different areas. So I'm going to go into this Mbezi River area. And here we can see that nice high-resolution orthomosaic that's coming in the web. But what's important about this is through this web application, I have a number of different tools available to me. So I can take a look at this layer list. And here I've got a couple of different editable data layers here that are going to help me determine or perform, I should say, a preliminary damage assessment directly from this orthomosaic. So what I can do here is actually adjust the transparency on my orthomosaic layer, and beneath I have my high-resolution satellite imagery. So we can see as I adjust the transparency that different features are coming in. Take note over here in this the river plain that is the floodplain later, where we can see that there have been buildings that have been washed out. So just with the simple transparency of the layer and the underlying satellite imagery, we're able to get meaning from this application. But we can take that a step further. I can actually bring in my OpenStreetMap building footprints layer. And they should show up here in a sec. There they go. And then we can confirm that there were indeed buildings there, at least according to OSM. The more data sets that we have, the better reliability we have on what's there. So I can pull in these footprints. I can go back to my mosaic, and here we're able to distinguish whether buildings were completely destroyed or if they're just majorly damaged. Maybe they've lost their roofs or possibly down to the foundation. So we can come in here and actually use our editing widget and then add data to our common operational picture for responders, where we can see that there's residential buildings that have been completely destroyed out here in the middle of the river. So I'm able to edit against this layer, add new points to my damage assessment. If I had more time, I could enter in all the attribute information. But then I can see other buildings here which have experienced major damage but aren't completely destroyed. So I'm able to go in there and edit directly from my WebGIS. And what's important about this is now my field workers can go out into the field and they can see on the map where they are, a location where a building once was that might not be there, and then they can work with local partners in order to best respond and rebuild there. So I was going to show you how this translates directly out into the mobile applications, but we're a little bit short on time, so I wanted to just jump ahead and move into the kind of more robust data management. Before I do that, though, we can also leverage some of the other tools, the widget here for measuring area. For example, if I want to look at square meters, I can generate an area where that was, I guess, taken out by this flooding. So let's change gears, though, and move over into the more robust workflow. So we mentioned that we had these drone to map output management scripts. So what are those exactly? So if we open up ArcGIS Pro, we've just got a base map here, and then in my catalog pane, I can open up my toolboxes, and here we can see I've got one toolbox called Drone to Map Manager. If I open this up, I have those two tools that I mentioned earlier. The one is the Manage Single Project, and the other one is Add Project to Master Collection. If I open up the Manage Single Project tool, it's a very simple interface, right? There's only 4 different parameters that I need to input. One is the drone to map project file. So if I go to my documents, and then I go down to drone to map, projects, I identify my Mosaic River, I select the drone to map project that I created earlier, right, with my 2D outputs, and it's going to read all the metadata from that project. It's going to bring in the projection. The only thing I really need to do is pick an output file geodatabase and choose a name for my Mosaic. Everything else is auto-populated from that drone to map project. This makes this really easy. When I select run, it's going to generate all the mosaics for me. And I'll show you what that looks like. Let's go into my databases, and then I've already created my output database for that drone to map manager script. And I'm just going to add all of the outputs that that script creates. So what we'll see here in a second is a lot of things, right? So first off, all these green footprints here, that's my single frame camera image repository. So if I right click this and look at the attribute table, I have a record of every single image that was taken in this flight. So that's 441 single frame images and all the different attributes that are associated with those images. So if I wanted to, I could filter on those, I can search on those. I also have my high resolution orthomosaic. I built overviews for this already, and I've got my my digital surface model. So this isn't so useful maybe for, well, outside of the single frame mosaic, but the orthomosaic and the DSM, putting it into this framework isn't necessarily that useful. It becomes more useful when we have a lot more flights that we're flying, right? So we get to this point using the manage single project, but if I want to cultivate or curate a collection of drone operations, then I can use this other tool, which is add project to master collection. With this, I select all the different Mosaic dataset databases that I have, and it's just going to ingest those into the master collection. And I'll show you what that looks like here. So right now I'm just pivoting over to another map, showing me Dar es Salaam and all three of those different flights that Andrew mentioned before. You can see that my time slider pops up, which is giving me the ability to filter these projects based on time. So we can leverage that there. But all this information also carries up into the web as well if we wanted to publish to our enterprise. So what we see here is instead of having the 441 single camera views for my single project, the footprints aren't coming. Let me just remove this and add it here. They should come up, and they're not coming up. I don't know why. Okay, but essentially what we have here is what you would have seen is that all of the images get loaded into the footprint for the single frames, and you have a catalog for something like 2,000 different images. So even with 3 flight plans, this might not be the most useful or the most most valuable use of your time. But when we start to coordinate in the 10s or 20s of these flights for a response, then you can see the need for managing these in these Mosaic data sets so that we can take advantage of not only the nice orthomosaics, the 2-dimensional products, but we can also come in and exploit individual images in image space. So if we go into our area here, we can take a look at our different images. I go to my data. I can explore my raster items. And here, instead of
Yes, Brendan, it sounds like we lost you there. I'm sorry, I thought it was just my connection. Um, Andrew, I wonder if we should move it over to you, and we should try to get Brendan back on.
Sure thing. Yeah, I think Brendan's internet connection must have dropped. So I think we could move on to the final section here. So, you know, bearing in mind that what Brendan is showing is the image management and analysis capabilities in ArcGIS for how to ingest, store, retrieve, and then put into an analysis framework all of the various imagery from a number of different drone data sets. I wanted to just end and then transition to Q&A by talking about a project that we have upcoming that also addresses, I think, the connectivity in remote areas problem for how we actually manage that within a WebGIS framework, which obviously would be a problem if you don't have access to the web. Can you bring up my final slides here?
Yeah,
Fred?
you should have control at this point, and
Here we go. Got it.
there you go.
In the week of upcoming August 5th to 11th, we're going to be working with Amazon Web Services with support from Esri, colleagues at the Harvard Humanitarian Initiative, and then our Peruvian colleagues in INDESI, the Peruvian Air Force, which does quite a bit of the disaster response in Peru, and of course Peru Flying Labs, around how we can deploy new edge computing solutions for management of a WebGIS environment for drone analysis and data management in a remote area. The project is going to take place in Madre de Dios, which is an area towards the Bolivian border, straight in across the mountains from Lima. It's a heavily forested area, very remote, has routine problems with flooding, and is a site much like I was describing with the Maldives earlier, although in an archipelago context where there's regular small-scale disasters, and the disaster management agency is interested in kind of figuring out how we work in that environment with drone imagery. We're going to be deploying something called the Snowball Edge, which is a new version of the Amazon Web Services mass storage device. So this is a 100 terabyte device that contains a local compute instance of Amazon EC2, so we'll be loading up ArcGIS Enterprise Drone to Map, ArcGIS Pro into that compute environment, and then it works entirely outside of the boundaries of internet connection to the broader internet. We'll be able to coordinate a half dozen or more simultaneous drone flights that will then feed off the same WebGIS environment, so that hopefully addresses a number of the data pinch points that I was mentioning earlier. That then coordinates into produce this final focus around not just image products, but image applications, so that we're able to guide towards damage detection, structure, feature identification, land classification, and other things in an application environment where we're not trying to work directly with image data transfers to disaster decision makers. Again, the focus here, this is the Tanzania team. Just great thanks to them for all of the hard work to be able to get that work done earlier in Tanzania, and there's a lot of ongoing work to ensure that this stays effective and continues to improve in a local context going forward. And that is what I had for now. I think we have about 15 minutes for Q&A, and I think Brendan may be back. I'm not sure.
Yeah, let's see if Brendan is back.
I am. Sorry about that. I got a blue screen, so timing was great on that one.
That's terrible. Well, why don't we move to Q&A? There were a few questions that came in. We'd encourage everybody to post more questions as we go along here. And if there's time towards the end, maybe we can catch up on the rest of your slides there, Brendan. But the very first question came in while Andrew was talking, and it said that you mentioned you wanted to minimize planning efforts and increase time for quote-unquote work. What's the path towards that? Are there tools you have in mind? Does work also involve, or quote-unquote work also involve data analytics and maybe use of AI for analytics? And you covered some of that, but it might be interesting to get some deeper insights.
Yeah, I mean, I think it's a lot of things, actually. So, you know, you could start with improving the tasking process. So a big part of the planning effort is around just identification of areas of interest, making sure that we know who's flying where, what their intended product is, and then returning that product back to a kind of common data management and analytics environment. We've been experimenting with the use of an application called Hanger for that. There's been field testing ongoing on that. I think there's a version of that that could be well done within Esri to be able to identify based on baseline imagery and other kinds of reports, kind of where flights ought to take place, and then create a feedback loop so that if we, often it's not clear from the initial flight what needs to be done. There needs to be follow-up flights. There needs to be a kind of loop created to ensure that we're able to collect information that's appropriate to the decision-making framework. So that I think is one thing. I think the other, to your AI point, I mean, personally, I'm sort of two minds about this. One is that I think often we think that big data management here kind of automatically means that we need automated production of a large amount of information. For sure, we want to get to a point where that's part of the toolkit. So like the data sets I showed you on the tree identification, looking at specific species, machine learning frameworks that are able to rapidly identify specific types of features in an affected landscape, those help to speed up the process of kind of extracting vector information quite dramatically if we're able to have them. There's a whole bunch of caveats that have to be made to that, though. I mean, often those really are dependent on local knowledge, on specific requirements around camera sensors and other classification databases that we have to have available to do that work. And I think we don't really want to make big data analysis equivalent to automated feature extraction, actually, which sometimes happens. There's quite a lot of work that has to be paired with that in terms of the kind of field management workflows, identification of points of interest, identification of features on the ground that you know, come through manual identification as well. So I think making sure that we can link that in a common GIS environment makes it so that we could use both techniques of automated and manual detection to do our analysis. Having models available prior to that for things like hydrology also improves the data preparedness element so that we're able to load that up prior to the event and make sure that we're building hydrology models, say, into an appropriate flood analysis and then handing off the results of those models rather than expecting decision makers to do that. I think that's really a workflow issue, and then having those data sets loaded in advance in the appropriate context that lets us do that sharing.
Yeah, that kind of ties into another question that actually came in. It was the third question that came in but for Brendan, in terms of, you were showing all these different layers and different things that you can add to the UAV data you collect. Like you were looking at the OpenStreetMap data and all that. So the question there was, is that type of data already available in ArcGIS, or do you need to kind of find that data and add it yourself?
Yeah, that's a good question. So the baseline base maps, the high resolution base maps, are available in ArcGIS Online, and there actually is a new tool that gives you historic base maps as well. So not just the the latest or the best. You can actually look at historic base maps for a given area. So that is there and it's ready to go. The high-resolution orthomosaics, of course, were generated from the drone flights in Tanzania. So those were just simply tiled and uploaded into ArcGIS Online. The OpenStreetMap data is actually it's not available to the public yet, but it is it's a layer that I have access to for like building footprints for OpenStreetMap. The option there would be to kind of extract and then publish those building footprints or other OpenStreetMap layers that you could then bring into your WebGIS and would be shareable to the public, or not to the public, to your stakeholders that are working with you.
So might that be available to people on this call through a subscription or some license agreement with Esri, or is this something people need to get hold of themselves and load into their ArcGIS environment?
Yeah, so basically if you have ArcGIS Online, then you have access to the capabilities to publish your own data or to pull in like the high resolution base maps. The OpenStreetMap data is not there currently.
Just a note, I mean, OpenStreetMap vector data is available through a number of other sources, so you can definitely always pull that in. There's actually a number of, there's some tools also through Amazon Web Services that folks have identified to be able to utilize that OSM base data as inputs into feature detection for structures for areas where OSM is not complete, actually. So there's a project through Development Seed and SageMaker that was interesting and provocative, at least, that can look at using the OSM data that Brendan was showing as classifiers for building areas that then allows you to do predictive work in the image for identifying areas that have not manually been identified, through the OSM editor process. So I think there's, and these things are going to converge more and more over time. That I think is something that is just a question of working out data access services and workflows.
Excellent. The second question that came in was around skills building or capacity building. The question was, while capacity and skills in flying UAVs is improving, where can people find training resources for the evaluation of UAV data? Are there training programs emerging within the academic sector?
So I guess I can plug some of our resources. I know for drone to map and some of the other analytical workflows, whether it be classification, et cetera, there are free resources from the learn.arcgis.com site. It's a really great resource. You don't need to have any subscription or anything. If you have a subscription, that's great. But yeah, you can get access to some interactive tutorials that give you access to the software and let you kind of kick the tires and develop that kind of baseline skill set that you could then explore and develop into your own areas of interest.
And yeah, there are other academic programs that are obviously focusing on this type of question increasingly. I mean, the Harvard Signal program also for satellite imagery is one source for that. They run kind of regular courses in this area, and we can circulate some resources maybe afterwards around other training and course materials. We're just completing the WeRobotics virtual course, which contains one section on imagery and analysis, and will be rerun in the fall. So if we wanted to add that on later on, we could add those resources.
Yeah, that would be great. And it sounds like you might have something, not only training yourself, Andrew, but WeRobotics, that you also have pointers to other resources that are out there. We certainly would be more than happy to plug those resources, or include those resources in the webinar postings so people that are listening in here or watching the recording can have ready access to that. So if you have a list, that would be great. There was no last question that came in to me. I'm going to read it back to you and I'll post it. With regards to building capacity, there are examples of training between the Tanzania Data Lab and the Tanzania Flying Lab to augment capacity of local Tanzanians. We're looking into ways to augment Tanzania data science capacity with the University of Dar es Salaam. So it's more of a comment, I guess, than it is a question. But you talked quite a bit about your Tanzania team, and as you work with these teams around the world, Andrew, are these people? What resources do they use to gain all these skills? That might be a good closing comment or closing question.
Yeah, I think there's a lot of them, actually. I mean, I think one of the things to observe is just that we're constantly encouraged and in some cases surprised by the really impressive quality of the work that folks around the world throughout the Global South are doing. And this is one of the points of building the Flying Labs Network, is to make sure that we're able to do that incorporation of that talent, to connect them together and to make sure that there's mutual support and learning going on. We've had support from Esri in doing that, actually, in setting up a shared GIS environment so that all the labs have access to these kinds of tools and can utilize them to do a range of different kinds of work. We've had really strong collaborations between, we've had run trainings in Tanzania, a couple of different ones. There were participants from Kenya, for instance, that were in our initial training that then went on to form a flying lab in Kenya. And likewise, we've had participation from other regional countries that have gone on to inform projects in their own areas. I think we have maintained a roster of support for international folks, many of whom actually have sort of significant data science backgrounds that can participate in providing advice, support, and sometimes direct project support to folks within the various labs, including Tanzania, but not limited to that. Some of the kind of mutual, recent mutual advice projects, actually, in the Tanzania case, came through utilizing underwater robotics, where our team from Fiji actually helped to conduct trainings with folks in Tanzania on how to deploy underwater drones for photographic analysis. So that's definitely part of the agenda going forward. I think there's a lot of different ways that can take place, and that's a kind of core principle that we're trying to maintain.
Wow, a lot of opportunities for sharing lessons learned and educating each other. This is not necessarily something there is established master's programs for quite yet, I can imagine. Well, we are close to the top of the hour. I think it remains to thank Andrew and Brendan for a super informative session here. Andrew and Brendan, if we can work with you on posting some of those additional resources, that would be fantastic. We'll get also the questions over to you in a follow-up, and if there's an opportunity for us to maybe embellish the answers a little bit in a separate document, we'd be happy to post that as well. But thank you also to the audience for great questions and for your interest in this subject matter. Please feel free to share the mail that we're sending out to your colleagues that may have interest in watching the recording. So with that, I wish everybody a great rest of your day, and welcome you back to our next webinars that you'll find on the event link on the NetHub Solutions Center. Take care, everyone. Have a great rest of your day. Bye-bye.